Go ahead. Okay. Good afternoon, everybody. My name is Mark Lenigan, and the title of my talk is Hacking Your Way into the APRS Network on the Cheap. We'll just kind of roll through this because this is originally a much longer talk. There, you can see the longer version of it on Iron Geek's website in the Nauticon 11 archives. I'd just like to start off by pointing out that this is supposed to be an introductory talk, so we're not going to get really deep into the like the low-level protocols or the specification of APRS and how the back end of the network really works. It's more like how to develop your own hardware or software systems to get on the network itself. And it by no means is exhaustive in its coverage of the field of even APRS, because there's so much out there, and even in the few months since I first gave this talk, there's new developments. So it's a pretty rapidly evolving space in the amateur radio world. And I also, for anybody who doesn't have their license, which I kind of expect most of the people in this crowd do, you need a technician class license or higher, which is the basic license in the US to get on the APRS network, at least on the VHF side. There are HF parts of the network as well, which you would need a general or extra license to access those bands. But the tech exam is 35 multiple choice questions from a pool of 350 published questions and answers. So you can memorize the answers and take the test and get the license. And there's they're not really showing up well on the blue background, but there's free study guides from www.kb6nu.com and free practice exams available from the ARRL.org website and qrz.com/hamtest. The license costs $15, all of which goes to the FCC, from what I understand. So moving on, we'll start with the history of packet radio. One of the early examples of it was called the LoHaNet in Hawaii, and it was a research network built by the University of Hawaii in the very early 1970s. It was a 9600 baud full duplex network, or well, duplex network, I should say. It wasn't. I don't know if it's full duplex or half duplex, but it could sense collisions so that the requests from remote stations were being sent to a central radio station on the island, and that radio station would reply back on several different frequencies, each of which the remote stations knew about. If two stations transmitted to the central station at the same time, the system could sense that collision and resolve it by basically the same way that 802.3 Ethernet does it. It had a standoff timer system. And the research network led to technologies like carrier sense multiple access, collision detection, the GSM cellular standard, and of course Ethernet. There's also ARPANET, which probably most of you already know. That's the prototypical forerunner of the modern internet, and started from a cocktail napkin. Where packet radio and ARPANET intersected was the packet radio van out in, I believe it was in San Francisco and Palo Alto, where it was built. But it was a bread truck outfitted with UHF packet radio and a PDP-11 inside, also with its own air conditioning unit. And in the 70s, I think that's all the truck carried, because all that stuff was big. The first transmission on November 22nd, 1977 is considered by many to be the start of the internet. And the early transmissions were made from outside of a biker bar. So the internet was weird from the beginning. This is actually what the packet radio van looks like, and it's currently on display at the Computer History Museum in San Francisco. There's also AMPERNET, which is the amateur packet radio network, which I believe got started in the late 70s or early 80s. And some forward-thinking individual decided to apply for a Class A IPv4 subnet back then. So hams have access to their own IPv4 Class A. But AMPERNET has kind of been falling apart in the last few years, and it's now mostly defunct. I was talking to some of the old hams here, and they can't remember of any parts of it that are still going. But there might be some remnants out there. So now we get to the grist of the matter. The amateur packet reporting system is what APRS is usually expanded to mean. Older versions of it called it the amateur position reporting system. And the name's derived from Bob Berninga's call sign WB4APR. According to his specification, it's designed as a two-way tactical real-time digital network sharing information about events in the local area. He initially developed APRS in the late 1980s, although there are some forerunners. And the entire network uses Bell 202 analog frequency shift keying at 1200 baud. I should also point out, the entire network is, at least on the RF side, a connectionless broadcast network. So you don't necessarily have to wait to see if anyone else is on the frequency. You just transmit, and if there's a collision, oh well. However, it's really scary how well this actually works for how stupid it is. And the advantage of the network is that it can operate standalone, and you can use it just on the RF side, but there are many devices on the network, on the RF side of the network, that will connect it to the internet in various ways. In most implementations, it's a simplex digital network, and there are several different devices on it. This is not exhaustive. There are trackers, which track the positions of objects, vehicles, people, etc. Basically anything you've stuck a tracker to. Digipeaters are basically a repeater for the network, but they're simplex. The signal comes in on the frequency, and it just boosts it much like an Ethernet repeater would, and retransmits it. And then iGates, these are the devices I was talking about earlier. They will route received packets on the RF side of the network to the internet, and if they're actually conforming to spec, they will also accept packets from the internet and transmit them out. So like two people could be sending text messages back and forth from one side of the country to the other, and most of that journey would probably be traversed via the internet itself, and only at the ends would it be on the RF network. And then, of course, there's weather stations, which are all over. There's probably at least dozens around here if you look on the APRS.fi website. And NOAA actually listens to the APRS weather stations and takes all of that data and puts it into their models. So if you're listening to their weather broadcasts or any of their weather predictions, they're relying on amateur weather stations for some of their local data. The frequencies for APRS in the US, it's almost always 144.390 megahertz in North America, and in Europe it's 144.800 megahertz. Other countries standardize on other frequencies, and it's kind of a hodgepodge, so I'm not really going to go into all of that. Occasionally, particularly in very congested areas, you're going to see APRS traffic on UHF in the 440 band or the 900 megahertz band, and very occasionally, but I seem to be hearing more and more about it, there's APRS traffic on HF bands like 10 meters and 30 meters. In fact, just recently in the last couple years, there was a guy on a tramp cargo container ship who was tracking his progress around the world on APRS, and the station that was receiving all that traffic was actually here in Kentucky. Applications of APRS, position reporting, remote telemetry for weather stations, amateur weather balloons like Project Stratocube that I'm working with. The network also receives traffic from the AIS network, which is what boats and ships use for position reporting, collision detection. Basically, they're always beaconing out their position and also their size, so that if you're on a narrow channel, you know whether or not you're going to pass a cabin cruiser or a 1,000-foot freighter. Usually, a lot of the amateurs on the network, when they're on their comment section in their packets, they'll mention what frequency they're on so that you can contact them as they're traveling or that sort of thing. There's also text messaging. I've used this. It's basically like SMS text, with the exception being that both parties have to be on the network active at the same time. There's no store and forward function that the network has. You can also use it to send email, but you should probably use the WinLink system for long emails, because it's considered bad practice to tie up the APRS network for minutes at a time locally, because it's one frequency, so you're exhausting the resources. There's also Mike-E, which my understanding is that's the position reporting of voice transmissions. I believe it's like a chirp that occurs at the end of the transmission. Also, you've got an AFSK 1200 packet at the end of your transmission, and I've also on the network seen it used for marking positions of events like tornadoes and wildfires, things like that, particularly in the Southwest. A group in Phoenix does a lot of tracking local wildfires on APRS. And I've heard of it being used as for locations and current statuses of search and rescue teams in the field, so that they could, inform base of, we're still searching, our vehicle's stuck in the mud, we found the person we're looking for, just by updating their text status on the network. This is what APRS.FI looks like. The longer talk, I did a live demo, but here, this is actually a screenshot from ShmooCon this year. This is my tracker on my cell phone that I fired up as soon as I landed at Baltimore International Airport, and that's why I'm inside the airport boundaries legally. And then here, I don't know if it's very visible, but Bob Berninga was actually driving by the airport as I landed. That's WB4APR. He was driving by in his Prius, so that's why I saved it, because I thought it was pretty cool that some of the first packets I captured were from him. And you can see here, actually, these WXs are weather stations. I don't really see too much else going on in this image, APRS-wise. Somebody else was driving along, what is that? 795 freeway in Maryland. But basically, if you go to APRS.FI, you can search based on call sign or SSID or location, and it will show you all of the most recent traffic on the network, sometimes as far back as a week, depending. For hardware, you need an amateur radio, a GPS unit for position and time information, and a TNC or other packet modem. Originally, these devices all cost hundreds of dollars, and many hams tried to homebrew their own gear with mixed results. There's a lot of stories about guys with like a piece of plywood tacked onto their dashboard and a whole bunch of stuff breadboarded together, and they're always talking about how this or that connection failed, and reliability was a big issue with that stuff. On the other end of things, there are commercial APRS capable radios. Mostly, I know of the Kenwood and Yazoo units, and they're highly integrated and full-featured. They're also expensive. For example, I'm going to ignore the Gen 1 units because we don't have a lot of time here. But like the THD72A is about $500 these days. The THD710A is somewhere around $700 when you fully kitted it out. And like the Yazoo VX8 is in the $350, $400 range. Which brings us to how do you get down on the low end. KD8 RTT of, I believe he was in Cleveland, Ohio. He's a college student, so I don't know where he is now. But he developed what he called the $30 APRS tracker using a Bofeng UV5R HT, which is this little guy here. They're now about $45. He also used a stereo audio patch cable, a surplus Android phone, which I have a box of those at home. I think everybody else here does, unless you're an iPhone person, and we'll get to that in a minute. And the APRS Droid app from Google Play, which you can download for $4.95 or sideload for free. On the iPhone variant, you could use Pocket Packet or any Open APRS from the iTunes Store. And basically what happens here is the phone reads the GPS position, generates the AFSK 1200 packet, and sends it out the audio jack, and you've patched that into the mic jack on your radio. So now the radio in Vox mode is transmitting the packet. And it actually, he proved that it worked pretty well. This is his setup here, and I used it as my first slide. He mailed this from his parents' house in the Cleveland area to his university in Indiana. And in the 2 days that it took UPS to move the package between those locations, he actually found that he was able to retrieve 4 packets on it, which is pretty amazing because he had no control of the orientation of the radio or the antenna or the placement of it inside of the UPS truck. But basically, when it seemed like whenever the system, the tracker, got within about 400 meters of a digipeater or iGate, those parts of the network were able to read packets from his tracker. There's also the TNC Pi kit for Raspberry Pi. I'm going to assume most people here know what a Raspberry Pi is. And 700 megahertz microcontroller that takes an SD card, etc. And for about $100, you can build the TNC Pi kit and then connect it with cables to your radio. And it actually is, it's like, I don't know what they call it on Pi, but on Arduino they're called shields. It kind of sits on top of the GPIO pins of the Pi. And I'm very interested in this system because connecting a full-featured Linux box to your APRS tracker, you could do things like have it generate events, using things like cron jobs or whatever, or connect it to a database and, change in time what your tracker is reporting or what you're beaconing into the network. So like if you have a hackerspace, you could announce your meetings to the hams in the community, like, hey, it's Tuesday night, our meeting's at 7, stop on by. You might also be able to use this on the WinLink email network, but that's outside the scope of this talk. On Arduino, there's a lot of different kits. I haven't really seen one of them stand out more than the others, but there's BirdOS, the Tracduino, the Adafruit APRS Shield, and the Argent Data APRS Shield. There's also EXT Digi software, which is an image for the Arduino that you can load onto it. It still needs the GPS and radio connections, however. On Beaglebone, I used to say that there really wasn't much going on here, but recently the same people who make the TNC Pi have made TNC Beaglebone. It's adapted for the Beaglebone and similar in price. There's also open source software packages. Both of these are now in at least the repositories for Ubuntu. There's Sound Modem, which hasn't seemed to have been updated frequently, but then again, it does everything already pretty well. And it converts your sound card on board directly into a TNC, which you can then use patch cables into your radio and set up your, basically you set up a software TNC packet station that way. And then there's Zaster, or at least that's how I pronounce it, which I would say is currently the state-of-the-art Unix APRS software. And both of these will require you to have AX.25 modules compiled into your kernel and the APRS-D daemon to be installed and running. I would also point out there's also, it's called Yak, yet another APRS client, which is not in the repositories, but it does a lot of the things that Zaster does. It also allows you to send WinLink email through APRS digipeters. So if you're out of range of the local WinLink VHF node, you can send email that way, in very remote areas. For future directions, I haven't seen too many people using the RTL SDRs, but they could be configured as a receive-only iGate. I'm personally really excited about the HackerF and the Jawbreaker stuff that has been real soon now, because you could configure it directly as a digipeater, iGate, etc. And I think it might allow for something like frequency hopping spread spectrum modes, which would be interesting on packet. And it could also be really useful to digipede on multiple frequencies simultaneously in congested areas like Chicago, where you have a lot of traffic. Since this was originally at Nauticon, I also mentioned that the microcontrollers on the Nauticon badges might be hackable as well. And I think that's about it. So I'll open it up for questions. Yes?
So APRS is, what about security around that? Because I know a lot of times it gets used in emergency situations. Take for example, local, we have tornado through Henryville, this north of here. APRS was used for search and rescue assessment tools. One of the problems we get into though is security around what's being sent back. Names, personal information. Any kind of thought on how to develop it? There's been, I guess, some desire to add security encryption to ham radio, which is currently not legal.
Yeah, I know there was a request for rules change into the FCC. I think the FCC declined it based on a lot of the comments. But I know there's been a lot of attempts to modernize amateur radio's regs that way, which is holding us back. Like really at this point, the technologies could surge forward, but we're held hostage by rules that in some cases go back to World War II. The only thing I could think of is, I mean, in the current state, it would just be, taking care not to transmit that information. That's why I was saying, like in the search and rescue thing, the person of interest or whatever. And doing that, I think would just, I mean, it's basically just observing basic privacy practices. That's the best we can do right now. But yeah, the security and authentication and things like that are places where we could definitely improve amateur radio's digital technologies, but the law holds us back. Any other questions? Yeah, we're talking about the Federal Communications Commission, which they, like, Part 97 that governs amateur radio is actually in the U.S. Federal Code. I don't know which title it's under, but literally it's federal law. So if you break it, you're committing federal offenses. And I haven't ever heard of people going to prison for this, but the FCC is not shy about handing out very hefty fines, like tens of thousands of dollars, sometimes close to $100,000 for breaking the regs. Other questions? Yes. Your question is there any headers to the packets so they know where to go to? I don't believe so. Like I said, it's connectionless and broadcast. So, if you wanted to do something like that, probably running your own, like running on a separate frequency and then running a station that would digipede on both the normal APRS frequency and on your frequency, then you could, you could sort the packets at that multi-frequency digipeater if you wanted. A lot of the weather balloon projects do stuff like this because they make the weather balloon deliberately very chatty, that it's returning a lot of telemetry, and they don't want to overload the local network. So like their ground station will receive all of the telemetry and then maybe only digipede one packet every 4 minutes. Any other questions? Thank you.